or least common multiples. Using prime factorization allows you to identify greatest common factors and least common multiples. I do not do what they show in example 1. I feel like what they're showing you in example 1, the factor tree method, takes too long. Now, if you like the factor tree method, there's your example, okay? But I do it division by primes. Percy calls it the tower. And that is the way I do it. Okay? Now, you know how when we divide, normally you'll go like 64 divided by 2, and you go and you finish your division over here? Well, because division by prime requires a multi-step division process. Percy, did I show it to you guys this way going down? Or did I go up?
You always started down.
Okay. I prefer going down because it's just, then, you know how when you start down, you go up, you might run out of room. So this is the exact same thing as this, okay? It's just upside down. So we're gonna do their example 1, but I'm gonna use the division by prime method, okay? And everything is the exact same thing, only flipped over. The question you ask yourself is this number divisible by the first prime, which happens to be 2, right? Is this number divisible by 2? Anybody know? Yep. What's the result? 468. Please check my arithmetic. Okay. You continue to ask yourself this question until the answer is no. Is it still divisible by 2? Is 468 divisible by 2? Yes. Draw another box, divide it by 2, and there's your new quotient. Is it still divisible by 2? Yep. And I think this is where our story ends. Draw your little doodle bopper, divide it by 2, and you should have 1, 1, 7. Okay, if I'm wrong, please yell at me. Is this still divisible by 2? Once the answer becomes a no, you say, is it divisible by the next prime, which happens to be what, folks? 3. How can you tell if this is divisible by 3? Do you guys remember that little rule? The sum of the digits, 7 plus 1 plus 1, if that is divisible by 3, then it is. So yes, it is, because 9711 is divisible by 3. Okay? So 117 by 3, 39? Is it still divisible by 3? Uh-huh. Boom, boom. Is it still divisible by 3? No. Next prime is a 5. Is it? No. 7, is it? No. 11, is it? No. 13, yes. You could have already jumped there. I know most of you would have, but I'm just showing you the process. Ask yourself about each prime. 13, yes. And once the quotient at the bottom of your tower is a 1, you have now found the prime factorization of the number in question. Okay? So the prime factorization of 936, and by the way, I always use exponents to express all this. 2 cubed multiplied by 3 squared by 13. Okay? This is the division by primes method. And what it does for you is it eliminates all that extra work. Okay? The factor tree method that they show you The tree method is kind of arbitrary. You can basically come up with any factors and you just keep dividing until you get to nothing but primes. Whereas this one, you choose primes off the bat and you just get there much more quickly. So anyways, that's what this method is right here. Okay, now the reason this is important is going to reveal itself here in the next example, or the next thing I'm going to share with you guys. So this is my example 2. We're going to leave that book example alone. Here's my example 2. Example 2 says, find the greatest common factor and least common multiple of the following numbers: 20 and 28. Okay, greatest common factor, least common multiple. Step 1, prime factor them. It's going to be a lot faster than the number 936, don't you think? Prime factor them. Starting with a 2. And I'm just dividing them both at the same time. You can do it separately if you want. Am I losing anybody here? I'm trying to kind of go quickly because I feel like you guys are probably okay with this. Yeah. Continuing, they're both still divisible by 2. And we end up with a 5 and a 7. The 5 is divisible by 5. The 7 is divisible by 7. Okay? So 20 is 2 times 2 times 5. 28 is 2 times 2 times 7. Now what does that have to do with anything? Well, for the greatest common factor, take the least power of shared factors. And I'm going to illustrate that down here actually. 2 squared, 5, 2 squared, 7. And it's not really clear with this one because they actually both share 2 squared. Okay? They both share 2 squared. Would you agree with me that they both share 2 squared? And the least of those that they share happens to be what they share, which is 2 squared. Therefore, the greatest common factor is 2 squared. Okay? The least common multiple is no longer about what they share necessarily, but it's about the factors themselves. For the least common multiple, you take the greatest power of the listed factors. And we're going to practice this a couple times, so don't feel like this is baffling, please. Okay. We do have 2's showing. Would you agree? What is the greatest power of the 2's that show? Well, 2 squared, right? Do we have any 3's showing here or here? Do we have any 5's showing here or here? 5 appears once. Do we have any 7's showing here or here? 7's appear once. That is the least common multiple. 4 times 5 times 7, whatever that is. Okay? And if you look in your textbook on page 180, These two definitions are listed under example 2, letter A and letter B. We're going to practice another one just like this, okay? Just so that you can see it with a little more variety, okay? Because I feel like having 2 squared just made it too simple. Can I flip? Okay, this is another example 2. And this time we're going to do least common multiple and greatest common factor. Remember, greatest common factor is one thing, least common multiple is something different, of the following numbers. We're going to do 100, we're going to do 120, and we're going to do 90. 100, 120, and 90. Start by factoring them. All of these are divisible by 2, right? 50, 60, 45. Are they all still divisible by 2? No, just these two. This. But this guy is now divisible by what? 3, right? 3 is the next one it's divisible by. 25, 30, 15. He's divisible by 5. He's still divisible by 3, or he's divisible by 3. And you are still divisible by 3. Okay, continue with the smallest possible prime. What? 2. It would still be 2, you're right. Thank you. 2, 15. Thank you. Continue with the smallest. 5, 1, 3, 5, 5, 1, and now we're down to 5 and 1. Okay, so for 100, the prime factorization is 2 squared, 5 squared. For 120, the prime factorization is 2 cubed, 3, 5. Nope, 2 cubed, 3, 5, yep. And then the last one for 90, it's 2, 3 squared, 5. Now the rules were greatest common factor is least power of shared factors. Okay, do they all share a 2? Yeah. But what is the least power? 2 squared, 2 cubed, or 2 to the first? 2 to the first. Do they all share 3? Nope. Do they all share 5? Yeah. Least power. 10. Okay? What's your question? Jazz, what's your question? Least power of shared. Okay? Do they all share a 2? Jazz. What's the least power? Really? So you're saying this is 2 squared right here? Least power. Okay, so there's the 2. Do they all share a 3? No, which is why it's not listed. Do they all share a 5? Okay, least power is 1. Least common multiple, a little bit different, is the greatest power of any prime factor showing in the lists. Let's start with 2's. Are 2's anywhere in this mess? Yeah, it's in all of them as a matter of fact, but it doesn't matter even if it's only in one of them. What is the greatest power of 2 in here? 3. Are 3 showing anywhere? What's the greatest power of any 3? Are 5s showing anywhere? Greatest power. Are there any other primes showing in these lists? Therefore, this is the least common multiple, which is what? 2 times 2 is 4 times 2 is 8. 8 times 9 is 72. What's 72 times 25? 1,800 is correct. Okay, least power of shared factors. They have to be shared among all 3 and then take the least. Or 2 if it was only 2. Greatest power of any showing. If they're in the list, use it with the greatest power. Okay? Now, when you have, going on to example 3, numerically, example 3 uses the same process for the number portion of the monomial. Okay? And technically, it uses the same process for the letter portion as well, but I'm going to show it to you. Okay? So here we go for example 3. And that'll be the last thing I share with you guys today. Example 3, we're going to do greatest common factor and least common multiple of monomials. I'm going to do a hard one. 32 x cubed y cubed 120 x y 4 and 42 x squared y cubed. Okay, start your division and only do numbers right now. Ignore your variables for right now. 2, 16, 2, 8, 2, 4, 2, 2, 2, 1. Did I just get 32 done? So 32 is equivalent to 2 to the 5th, right? Bring down your x's and y's, but just keep them with their exponent. X cubed, y cubed. Keep the variables just the way they are. Let's do 120. 260, 230, 215, 35, 5, 1. Bring down your numbers or bring down your factors. 2 cubed times 3 times 5, xy 4. What? Aaron's troublemaker, I know. Last one. 42. 221, 3, 7, 7, 1. Bring that down. 2, 3, 7, x squared, y cubed. Okay, the rule. Greatest common factor is least power of shared factors. Do they have 2's in them? They all share a 2. What's the least power? Yep. Do they all have x's in them? What's the least power? Oops, I shouldn't have skipped ahead. Do they all have 3's? No. Do they all have 7's? No. Okay, that's why I skipped ahead. Okay, so numerically, the only thing they share is a 2. You guys get that? They also all have x, the least of which is a first. They all have y, the least of which is cubed. Therefore, 2xy cubed is the greatest common factor of that mess. Okay? Least common multiple. Greatest power of any prime factor that is showing. For example, an 11 is not going to be a part of this because there's no 11 in here. So 2's have shown up. What's the largest power of 2? Yep. 3's made an appearance. What's the largest power of 3? 5? 7. Largest power of X? 3rd, yep. Y to the 4th. Go ahead and work that out. Tell me what the least common multiple is. I can tell you the variable part, x cubed y 4. Throw it in your calculator. Come on, Ben. Unless you're doing it in your head. Ben's doing it in his head for Pete's sake. She's right. 3360 x cubed y 4. If you can memorize this little rule thing, then these will happen rather quickly for you. Extremely, extremely useful.